All right. You'll hear the rest of the story next week. Just another time. So let's talk about a few things. I think a lot of you are putting a lot more stress into this quiz than really needs to be. So let's talk about, let's say you had a cylinder. But then on top of that cylinder, you have a cone. Okay? So let's dissect things we would need to know. If I was asking for the surface area of this object, okay, hang on. I have the bottom of the cylinder, which is a circle. Agreed? Yeah. And in order to find the area of that, that's pi r squared. That takes care of this. Agreed? Do I have to worry about any other circle finding the surface area of this object right now? No, the cone is sitting on top of it, so now you don't worry about it. So then we have to think about this portion. Okay? So that's a rectangle, correct? Yeah. So I have a height, so you're going to use the height times the circumference of the circle. Correct? So the circumference of the circle, this distance around here, or this distance around here, if I were to cut this apart and I would lay that flat, I would have a rectangle, and it just happens to be that if I had made this initial cut right here, like right down the side, and then said, oh, okay, let's try and start laying this out, it's going to eventually, as you first cut it, it's going to be curved because it's still trying to keep the shape it was. But then if you smash it down, it becomes your rectangle with those dimensions. So far, if I were to add those together, I would have the bottom and the lateral surface area of the cylinder. Then the last part is I have this cone up top. And do I need to worry about the base of this cone? No, it's adhered to the other base, so we're not looking for that as surface area. So we look for pi r l. Let's go. And this is an easy one to remember because RL is one of my best friends. His name's Rob Lieber. We always call him RL. So you should know that because you know my friends. Times pi. All right, so if you were to look for the total surface area of this object, you have pi RL added to pi r squared added to height 2 pi r. Okay, I didn't give you r. I mean, there'll be other things that will be labeled up here. So things that we have to decipher is we have a radius. We have the height here, and we have the L there. So that triangle looks like this. I would probably give you a height and a radius at a minimum. Okay?
Wait. So you can also you can find the surface area of the cone, right? Through the other equation of pi r squared plus pi r l.
Yeah, that finds you, so the pi r squared of that equation finds you the actual base, the bottom of it.
Also true.
But if you're not going to include it, if you had a cone sitting on top of a cylinder, you don't have, or let's say you had this. Let's say you had you have two cones stuck together.
Then you need.
You're not worried about the base at all. You just have this being pi RL and this pi RL over here. Do they have to be equal? No.
And then you're done, right?
Yeah.
Wait, why don't you ask me?
Well, if they were stuck together. If you're looking for the surface area, like think of it, if I took two cones and they had bases on them both, but then I glued them both together and I was like, oh, I want to paint this object now. You're not going to undo the glued part to paint that. You're just going to paint the lateral surface.
So you don't count, like if you have a cone on top of a cylinder, you don't count where they're connected.
Right.
Okay.
Make sense?
Yeah.
Yeah.
So if you want to find the total surface area of this, you would do pi
So So it would just be these two things added together. And this could have, height of this, and this could have a height of this. This has its own individual. The only thing constant between these two right now would be just the radius. Because I could have a cone, a really long cone like this, and then I could have a really stumpy one. So a little stumpy cone and a real long one. That would, still work. So, that's really all that we're looking for as far as this quiz goes. I mean, it's, you have to remember if you have a hexagon base. Okay, yes, we could go and say, hey, n minus 2 times 180, well, that's 120s. Well, the nice thing about this is this forms, I could draw it, we have an apothem, a radius, and 0.5 of our length, where this is actually a 30, 60, 90 triangle. Okay, that's if you have a hexagon. If you have a pentagon, this is a 108-degree angle. If I did my apothem, radius, and 0.5s, this angle here is 54 degrees. So again, n minus 2 times 180 divided by n. Okay, we've used it a lot. What's the difference between H and L? Okay, so if you had this,
The length is the side thing. That's height.
so that right there is height.
Yeah, length is the side thing.
And then the length is the side length going down. Okay, are H and L the same thing? If they are, it's called a cylinder. Yeah.
How do you find the lateral area?
Of a cube?
Yeah.
All right, so you might come across a problem. Actually, our very first problem on the test, we will actually define for what we have as the base. Okay, so if we have, let's say this is 5, this is 3, and this is 2. Okay, so if we wanted to find the total surface area, I have 2 rectangles that happen to be 3 by 2. I have 2 rectangles that happen to be 5 by 2. And I have 2 rectangles that happen to be 5 by 3.
Yes, sir.
So that's 6, that gives you 12. That's 10, that gives you 20. That's 15, that gives you 30. So if you add those all up, that's 62 square units. And we will work on number 1 together, because it says find the lateral surface area of this object. What's the problem with that? Yeah, what's the definition of a base?
It's parallel.
It's parallel. So I have a top and a bottom that are parallel. So should that be my base and I find all the way around the edges? Okay, that sounds good. Or could the right side and the left side be my bases and I find the lateral areas top, this side, bottom, back side? Sure. Or should I have my front and my back be my bases and I find the lateral surface area being the side, the top, this side, and the bottom? Okay, what's the right answer? There isn't one unless I have defined for you what the base is. Okay?
So then you can give any of the lateral areas.
Right. There's theoretically 3 different ways you can find the lateral surface area, and there are going to be 3 different answers depending upon, what base you're using. Does that make sense how I stated that? Okay. So, what was due today?
Not the test.
Okay, so worksheet what?
Story and take-home test.
I think it's the review.
A review was due on Monday.
So everything.
Worksheet review is Monday.
Wrong.
Worksheet review is Monday.
So it's 11.5.
11.5 is due today.
No.
Or do you want to make them both due on Monday?
Yeah, Monday.
All right, let's do it. We'll make them both due on Monday for
And
you.
let's not do quiz.
And all right, here comes the quiz.
Is it a take-home quiz?
No,
Dang.
like
He's giving us a
Um,
quiz class.
And then you wants to give us a head start.
So, the first question on the quiz. Dude, he's doing this whole thing. No, I'm not. So, the very first question on the quiz is this. Okay? So, I am going to say we will have the top and what we can't see right now, and the bottom as our bases. So what would the dimension on the top of and the bottom be? 5 by 3. How many of them do I have?
2.
I happen to have 2 of them. Okay? So you would need that to find the whole surface area. But if I ask you what the lateral surface area is, you're not using the 5 by 3 and the 5 by 3. You're using the other ones. Make sense? I'm going to leave that up there. Here comes the quiz.
No.
Yeah.
So those are the basics.
Yeah.
So